Welcome to the second video on parallel lines cut by a transversal. Alright, one thing I'm going to add to this video that we didn't talk about last time is that parallel lines are often noted with double arrows on either end, just so that you know which ones are parallel in case you're ever looking at a diagram and you're just not quite sure, or you're told not to trust a diagram, for example. Those double arrows mean that this line is parallel to this one. So these are two parallel lines. This is our transversal. Remember, it's cutting through two or more lines, and it creates these 8 angles. And in the last video, what we talked about were exterior angles. So 1 and 2 and 8 and 7 were exterior angles because they're on the outside of the parallel lines. And then we specifically talked about alternate exterior because they were opposite sides of this transversal. So 2 and 8 are alternate exterior angles, and 1 and 7 are alternate exterior angles, and their specific relationship is that they're congruent. Angle 1 is congruent to angle 7, and angle 2 is congruent to angle 8. I'm missing my congruent symbol there in angle 7. Alright, so that's the property that we learned about alternate exterior angles. We're going to now talk about these interior angles a little bit more today. So sticking with the same diagram, interior angles are the angles found between the two lines. So the exterior ones were outside, the interior ones are going to be on the inside. So let me just label this in here, interior. So angles 4, or let me just go in numerical order, angles 3, 4, 5, and 6 are all considered interior angles. So I'll just go ahead and label these. These are the exterior, and then inside my parallel lines, really the two lines that are, they don't always have to be parallel when you're talking about exterior, interior, but for this lesson, specifically the ones inside the parallel lines are called our interior angles. Now, alternate interior angles are going to be very similar to alternate exterior angles, except for we're only going to be looking at the angles inside of the parallel line. And alternate, again, alternate means that it's going to be on opposite sides of this transversal, and they're going to have the same relationship that the alternate exterior angles had. They are congruent. So alternate interior angles are congruent. So let's go ahead and figure out what the alternate interior angles are. So this obtuse angle over here, angle 4, is congruent to this interior angle, the obtuse angle over there, angle 6. Those two are alternate interior angles. They are on the inside of the parallel lines, but on opposite sides of the transversal, and that also leads angle 3 to be congruent to angle 5. Alternate interior angles, they are congruent, and just like with the alternate exterior ones, it will allow us to set up equations to solve for missing values and measures. Now, it just so happens that there is also a second relationship found with interior angles. So I want to talk about those two. Alternate is one that we have already talked about, and that is when we have the angles are on opposite sides of the transversal. So focusing on opposite sides of the transversal are the ones that match up with the definition of an alternate angle. Consecutive is the other side of this angle relationship, and that definition is when the angles are on the same side of the transversal. So same side is going to match up with consecutive, and I'm hoping that that kind of makes sense whenever we get into the diagram. Alternate is going to be the opposite, consecutive will be the same. Let's take a look. Alright, so let's break down consecutive interior angles. I'm going to start with the interior part because that's a little bit more familiar with us. So the interior is on the inside of those two parallel lines that we're going to be talking about. And then the consecutive is really the new piece here. The consecutive is the ones that are on the same side of this transversal. So same side. And so let's take a look at what I mean. Angle 3 and angle 6 are the two interior angles, they're on the inside, that are on the same side of this transversal. They're both on the right hand side. So 3 and 6 are consecutive interior angles. And this is where I hope it makes sense that they're called consecutive, because consecutive outside of the math classroom refers to one right after the other. They're next to each other. So 3 and 6 are the two angles that are next to each other here on the inside. So angle 3 and 6 are considered consecutive interior angles. And on the right-hand side, on the left-hand side of the transversal, it's the angle 4 and angle 5. Those are our other pair of consecutive interior angles. Now, as far as the relationship goes, it's a little bit different. Angle 3 is acute, angle 6 is obtuse. Well, when we were dealing with the exterior or the alternate ones, they were both obtuse, like 4 and 6 are both obtuse, so of course they matched up to be congruent. Angle 3 and 5 were both acute, so of course they matched up to be congruent. In this case, angle 3 is acute and angle 6 is obtuse, but they actually match up to be supplementary. So remember that what it means to be supplementary is that the angles are going to add to equal 180 degrees. So with using our angles that are here, I'm going to say that angle 3 plus angle 6 equals 180 degrees, or also angle 4 plus angle 5 will equal 180 degrees. And I'm actually going to erase the degree mark because that doesn't help us when we're actually solving. So that's the property that we're going to use for consecutive interior angles. Let's go ahead and take a look at some problems. So this first example, we're finding the value of x, and it keeps it pretty straightforward. There's nothing to solve here, it's just x. But what I want to focus on is why it is what it is. So x is going to equal 100 degrees. So x will equal 100 degrees, and I am going to go ahead and put a degree mark there because that's what x represents, an actual angle measure, not just part of a term or an expression. So the angles are on opposite sides of this transversal, and they are on the inside of the parallel lines. So x equals 100 degrees because, we'll say by alternate interior angles. So just also trying to focus on the explanation of why the angle equals out to be what it is. In the second example, let's figure out where x is. Okay? X is on the inside of these two parallel lines, and it is on the same side of this transversal. And so by consecutive, we remember consecutive interior angles are supplementary. So that means that they add up to equal 180 degrees. So x does not equal 72. And let's not make that mistake. X does not equal 72. X plus 72 equals 180 because they are supplementary. So if we subtract 72 from both sides, that will tell me that my value or my measure for x is 108 degrees. So that's the measure of x. When it's in a consecutive interior angle relationship, they are supplementary. Okay, so with this example, we have x actually in an expression now and not just as the angle measure itself. So whenever we go to get started with this, we just want to make sure that we're clear with where the information actually is located or where the information is that we're trying to find. So in this problem, these expressions are on the inside of those parallel lines, and they are on opposite sides of this transversal. So that tells me that I'm going to be using alternate interior angles and the fact that alternate interior angles are congruent. So the deal here is that we want to make sure that we're careful with is that to be congruent, it just means that their measures are equal. So when I set this problem up, that 45 plus 6x, I'm not going to write congruent, I'm going to write equal to 8x plus 15 because the angle measures are congruent, or the angles are congruent, but that means that their measures are equal. So we want to make sure that we're solving something with an equal sign here. So I'm going to go ahead and start solving for x. So it looks like for this one, we get x equals 15. I am not going to be putting an angle measure, or sorry, a degree measure degree label on the answer 15 because the x is part of an expression. It is not representing an angle measure. So x equals 15 by, once again, using the fact that alternate interior angles are congruent. If you're ever not sure about if they're congruent or supplementary, take a look, see if you can trust the diagram to a certain degree. This is an obtuse angle. This is also an obtuse angle. They're going to be equal measured obtuse angles. Last one, focusing on their interior angles here. Again, these are interior because our two expressions are located inside of those parallel lines. And if we're now referencing their location compared to the transversal, they are on the same side of that transversal, which means we're going to be using consecutive interior angles, which are supplementary, which means that the measure of one of them plus the measure of the other one is going to equal 180. So let's go ahead and set up this problem. So 3x plus 10 plus 4x minus 5 equals 180. So I'm going to combine like terms here and start solving. So for this problem, x is going to equal 25. And I'm not putting an angle or a degree measure on that because it doesn't actually represent a degree. If we did have to find the angle measure, we would have to plug the 25 back into where those x's are. And I'm pretty sure that if I do that, actually, I get 85 degrees here and 95 degrees here, which certainly does not match my diagram at all. This looks like the obtuse angle and this one looks like the acute angle. So these measures are not matching that, and not to mention the fact that this is a much wider angle than just a 95 degrees if I did actually have them in the correct spot. So just know that we can only trust the diagram so much as far as the looks of the angles, but we have to really go by how they're labeled with the tick marks for parallel and just their place value or where they're actually located. So x equals 25. Which is all we were trying to find in this one. So consecutive interior angles, alternate interior angles are two more relationships from their parallel lines cut by a transversal.